Okay, Year 11s, our quadratics work continues. So in this little series of quadratics so far, we've been looking at solving equations, quadratic equations, power 2 equations, up to 2 solutions by factorization, completing the square. Lots of fun to be had there. We looked at completing the square on something called the general form. So general form of a quadratic equation, ax squared plus bx plus c is equal to 0. Solving this by completing the square led to x equals, okay, pause, write this down, or pause and just say it out loud, just shout it out the window, or tell your mum or your dad or your brother or your sister or your dog what the quadratic formula is. Test yourself now. Okay, x equals minus b plus or minus the square root of b squared minus 4ac over 2a. Right. So what we need to do is we need to have a look at this thing and see what's in there. See, we'll break it down a little bit. So we've got under the square root, we've got this b squared minus 4ac, which you'd have to say is quite an important element of our quadratic formula, because it really does determine, as we discovered in, well, there it is there, that last example we did in the last screencast, when we had a negative number in here, we determined, well, there's actually no solution to this. There's no x that solves this in the real number system. And that is true. So that value, b squared minus 4ac, it does deserve some special attention, and it gets it, and it's got a name. As such, it is called the discriminant, which is the title of this screencast and this lesson, the discriminant. And the capital D in the Greek alphabet is this symbol here. That's delta. That's delta, and that is the symbol that is used for the discriminant. Okay, so when we talk about the discriminant, we're just talking about that value in there. So what we're saying is, let's be very clear, that the discriminant, which is that delta symbol, is equal to b squared minus 4ac. Okay, so its value is quite important to us. It determines, and that's why it's called the discriminant, because it discriminates the solutions to a quadratic equation. It is the discriminant. It's the determinant of what our solutions are in terms of what number system they come from. So if we have b squared minus 4ac, if that is a positive number, it means something very different to whether it's a negative number, or if it's equal to 0, or if in fact it's a square number. So we're going to look at all those cases now. Okay, so let's just block him down and let's start to look at the different cases. So if the discriminant is greater than 0, okay, so if we've got a discriminant greater than 0, then what we've got is, and this is how we will talk about it, we've got a value in here, and the plus minus here will dictate this plus minus. This is where we get our 2 solutions from. When we are, oh dear, I'm just deleting things. So this value in here, I just try to change my, there we are. That value in there, the plus minus, gives us our 2 solutions. So if we have a value in here, if the square root b squared minus 4ac is greater than 0, then we have 2 values. So we say we've got two distinct real roots. 2 distinct real roots. So we're quite careful with our language here. Distinct meaning different, 2 different real roots, because there is a case where we still consider 2 roots, but they're the same, they're equal. And that's when the discriminant is equal to 0. So when the discriminant equals 0, then what we have, if we split this fraction here up, then we get x is equal to minus b over 2a plus or minus the square root of our discriminant over 2a. Okay, so if the discriminant is 0, then this the fraction, it's plus or minus 0. So we don't have our two solutions now. We've only got one solution, and that'd be it there. It'll be minus b over 2a. That's the case when the discriminant equals 0. So when the discriminant is 0, we say that we have we still say we've got two equal roots, or a repeated root, but two equal roots is the right way to say it, even though it sounds a bit silly. We are talking about a quadratic, so we are entertaining two solutions. So we call them two solutions, but they just happen to be equal. Now this minus b over 2a, you might be familiar with that as well. So where have we seen that before? Well, that comes about, doesn't it, from our study of the quadratic and when it's graphed the parabola. And minus b over 2a is our axis of symmetry, or our vertex, isn't it? It's the axis of symmetry for our parabola, and it's also our vertex, or the x-coordinate of our vertex, the x-coordinate of our vertex. So let's think about that. That means that if we've got a parabola, and this is our x-axis here, then what we end up with, okay, this value of x here, so this is the x-axis, that is minus b over 2a. And what we got the same distance on either side here, you see. So we've got, these are the same distance to the next root here and the next root there. So the value of the discriminant actually determines how far away those roots are from our vertex, or our axis of symmetry, because this will be minus b over 2a plus the square root of the discriminant b over 2a, and this guy here is minus b minus the square root of the discriminant over 2a. Now, that's really important. So what I'm trying to get you to do perhaps a bit more in this course is to slow your thinking down and think deeply about some things that you just perhaps take as a given, or don't think too much about. It's really important to think deeply about what you might consider really simple ideas, because you might be overlooking some mathematical beauty, and I never want you to do that. So we've got our cases here where just greater than 0 equal to 0. Well, I want to consider two more cases. I want to consider if the discriminant is actually equal to a square number. Okay, because if the discriminant's a square number, you put a square number in here under the square root sign, then the square root and the square, well, they dissolve, they cancel each other out, they neutralize, and we're left with no surd. So if we've got no surd, then we're going to end up with rational roots. Rational roots. Rational roots meaning, right, we're going to have no square root. We're going to have fractional or rational solutions. And finally, I might just get rid of my little picture here. Finally, we consider the discriminant being less than 0. Okay, so there's such an example of the discriminant being less than 0 might be x squared plus 1 is equal to, or x squared plus 1 is equal to 0. So if we're looking at the discriminant now, then a is equal to 1, b is equal to 0, c is equal to 1, and my discriminant would be b squared 0 minus 4ac. So my discriminant here is negative 4. And you know that what x squared plus 1 looks like. X squared plus 1 is doing this. And you can see that there's no intersection with the x-axis. There's no there are no roots. There are no solutions. And so this is what a parabola of a quadratic that has a discriminant less than 0 looks like if also a is greater than 0, that meaning the coefficient of x squared. So if a is greater than 0, the discriminant is less than 0, it's going to look like this. If a is less than 0 and the discriminant is less than 0, it's looking like this. So in this case, when we've got a discriminant that is less than 0, what we say is, well, there's two ways of saying this. We say that there's no real roots. That's the kind of the negative angle on it. There's no real roots. And this word roots, really we're talking about solutions. We're talking about intersections with the x-axis. These are roots here. No real roots, or it perhaps might be more appropriate for us at this point in the course to entertain the fact that there are two unreal roots, or two complex roots, or two imaginary roots, all synonyms, all meaning the same thing. Two complex roots. So we need to be quite specific now that we say, well, there are no real roots here, and if we are in the complex number field, we have to go and find those complex roots, but that'll come later. Okay, let's have a look at some examples. Okay, so I'd encourage you to pause and do these examples perhaps, but or maybe let me do the first one, and then maybe you can go ahead and do parts B and C. Whenever you think you're ready to pause and have a go, then do that, because that means that these videos are really productive. Okay, so what we're doing without solving, determine the nature of the roots of each equation. The nature of the roots. So this word nature of the roots, they're talking about, well, these are the nature here. These two distinct, two equal roots, two distinct real roots. If it's n squared, then they're rational roots. So the nature of the roots. We're after as much information as possible about the roots. And in order to find the nature of the roots, we don't need to solve it. We just need to find the discriminant. That discriminates between the types of roots that a quadratic equation has. So the discriminant for a, let's go ahead and do that. Discriminant is equal to b squared. Right, so that's b squared, 7 squared, minus 4ac. I'd encourage you to use this kind of notation and just write everything down so that you're making sure you're getting 4ac in there, you're getting all your negative signs in place. Plenty of places to hear if you're hurrying, if you're rushing, if you're just trying to get the job done of making errors, and that's no good. 7 squared is 49 minus, now what have I got here? 4 5s are 20, I'm subtracting negative 20. So I have 49 plus 20, which is 69. Okay, so the first thing I know is that that's positive, obviously, so I'm going to have two real roots. Can I be more specific? Remember that underneath the real number system, we've got rationals, so Q for quotient, R for real, and irrationals, which is just a Q like this with a line through it. So irrationals, rationals. So yes, I know they're real, but can I also say they're rational? Well, they're rational if the discriminant is a square number. Is this a square number? No. So I say, therefore, I have two distinct real roots. That's as specific as I can get with this example. Okay, B, discriminant equals. Okay, well, firstly, the 70x is in the wrong place, isn't it? So I'm not ready for this yet. I need to write this as 25x squared minus 70x plus 49 equals 0. Now I can get the discriminant from negative 70 squared minus 4 times 25 times 49. Now 70 squared, 7 sevens are 49, so that's 4,900. Now I'm going to subtract what looks like 4,900. So I'm going to end up with 0 here. So what does that mean? My discriminant is 0. That means that this part of the equation here, I just end up with minus b over 2a. So I've got one solution, or as we like to say, therefore, two equal real roots. Two equal real roots. In fact, minus b over 2a, with b and a being real coefficients, then I'm going to have rational coefficients, then I could say that they're rational. Now C. Okay, so I've got the discriminant here, and this is in the format, it's fine for me, it's just fractional. 7 over 4 b squared minus 4 by a by c. So I get 49 over 16, and I'm going to subtract 4 times 2 is 8 times a half is 4. 4 is 64 over 16. So I'm left with negative 15 over 16. My discriminant is negative, so therefore I have no real roots. So now I've determined the nature of the roots of each equation. Okay, same deal. I'm going to just rattle out these examples, but I'd like you to solve as many as you can before I do. So perhaps I do A. I'd actually recommend that, because then you get to see the structure, the layout. You get to see exactly how I'd like it done, so that you're going to get everything you can out of the question, and then maybe do B and C yourself if you can. And then you can press play, you can speed me through, and you can just check your answers. Okay, so let's get to work. It's A, and on this question, find the value or values of the real parameter P, so that, all right, so what I'm doing here, I've got a quadratic 2x squared minus 3x plus P equal to 0. Now this is the world's my oyster here. The value of P will determine the value of my discriminant. The value of my discriminant tells me what type of roots I have. I want two real roots here. So, all right, I'm going to find the discriminant. It's going to be in terms of P, and then I'm going to solve it to get the number of the nature of the roots that I'm asked to provide. So my discriminant here is B squared, negative 3 squared minus 4 by 2 by P in this case. Okay, so that's 9 minus 8p. That all looks good. Now, let's go back. It has two real roots. So this has to be greater than 0. Two real roots greater than 0. So therefore, 8p is less than 9. I just put the 8p over this side. And therefore, p is less than 9 over 8. So when p is less than 9 over 8, I'm going to have two real roots. That's what that solution means. See if you can do part B yourself. Okay, let's do part B. My discriminant here, I'm going to rewrite px squared px squared minus 13x plus p is equal to 0. So my discriminant, which is b squared, negative 13 squared, minus 4ac. All right, so this is my discriminant. All right, I'm going to simplify it to 169 minus 4p squared. 169 minus 4p squared. And what I want has one real repeated root. So I want that to equal 0, one real repeated root. So therefore, I need my 4p squared to equal 169. So therefore, I need my p squared, when dividing by 4, to equal 169 over 4. And therefore, when square rooting, I need plus or minus 13 over 2. So I'm getting 13 over 2, 6.5, or negative 6.5. And when I have those values for p, I'm going to have one real repeated root. Okay, in part C, my discriminant here, I need to firstly p plus 2x squared plus 2px minus or plus p minus 1 equals 0. So my discriminant equals b squared. Now my b is 2p here, so it's 2p squared minus 4 lots of a, which is p plus 2, lots of c, which is p minus 1. That's a p minus 1 there. P minus 1 for my c. Okay, so that's my discriminant. Better do some tidying up here. 4p squared minus 4 lots of p squared plus p minus 2, which is 4p squared minus 4p squared minus 4p plus 8, which comes to just, once I've taken all that out, negative 4p plus 8. That's my discriminant. Has no real roots, so I'm solving less than 0. So therefore, I want my 4p to be greater than 8, and therefore p to be greater than 2. Okay, so let's do exercise 3D.